Hello everyone, welcome back to another video of Cloud Deep Dive. In today's video, we will talk about Amazon FSx for NetApp ONTAP. So if we talk about FSx, what is an FSx? F and S stand for file system, and what the mean of X here? X means your choice of workload. Whatever workload you want to run, you can choose that. And Amazon FSx provide a variety of workloads you can run, like Amazon FSx for Windows file server or for Lustre. And there's new two additions to this family is Amazon FSx for NetApp ONTAP and Amazon FSx for OpenZFS. So in today's video, we will talk about Amazon FSx for NetApp ONTAP, and this file system was added to this FSx family in September 2021. So let's first talk about what is NetApp ONTAP. NetApp is an industry leading software provider, and it powers 30% of on-prem NAS deployments. ONTAP is NetApp's data management software that supports a wide array of features that includes like multi-protocol, so it supports your SMB protocol, NFS protocol, iSCSI access protocol. So all this protocol is supported. Normally you have some softwares which just support one or two protocol, but it support all three protocols. Another is like replication between on-prem and FSx, or between the FSx is quite easy with that. Doing the snapshot cloning, data comparison and deduplication is very famous feature of this NetApp ONTAP, and it also has the intelligent tiering. So what is Amazon FSx for NetApp ONTAP? Amazon FSx is a file system which use NetApp ONTAP software, and whenever you create a file system, Amazon provide the infrastructure by using the ONTAP software which hosts your data. So if I give you a definition of FSx for NetApp ONTAP, it is a fully managed service that provide highly reliable, scalable, high performing and feature rich storage built on NetApp's popular ONTAP file system. It combines the familiar rich features of your NetApp ONTAP file system with agility, scalability and simplicity of a fully managed AWS service. The next concept come in Amazon FSx for NetApp ONTAP is storage VM, or we call it SVM. What is an SVM? So whenever you create a file system, by default it creates a SVM. An SVM is an isolated file server which has its own endpoint for doing any administrative task. Suppose you need to manage this SVM, so you have your own endpoint, you get it for that SVM, and you can put credentials on that as well. And then you get endpoints for your protocols, like for your SMB or NFS protocols, you get that as well. You can have either a single SVM in a file system, or you can have multiple SVM as well under a file system. So you create a file system, under that it create a SVM, and whenever the virtual machine is created, it needs a volume as well. So when you create an SVM, so by default a root volume is created of 1 GB, and in addition you get an option to create another additional volume where you can store your data. So AWS does not recommend to store any data on your root volume. It suggests or kind of recommend to create another volume and mount it at a junction path and use that volume to store your data. So if whenever you're creating a file system and it creates a default SVM, and if you don't provide or don't give any configuration for the additional volume, then by default it creates a 1 terabyte volume for you. But it also gives you option to create a volume of whatever size you want to do it. And these volumes basically they are the you can say that are isolated data container in which your files or directories or iSCSI logical unit for storage are stored. Next, I wanted to show this diagram which I got from Amazon website. So whenever you create a file system, like I mentioned, you can get one SVM by default, but if you want, you can create multiple SVMs as well. And under each SVM, you can have either one volume or you can have multiple volumes to store your data. At the file system level, you get two endpoints. One is management endpoint and another is inter-cluster endpoint. So management endpoint basically use if you want to perform any management task on the file system, so you can use this endpoint. And the inter-cluster endpoint is basically used if you need to set up any replication using NetApp SnapMirror or software, or by using NetApp Flex Cache. So if you need to do those kind of tasks, so you can use the inter-cluster endpoint. Now like we mentioned, SVM is a logical kind of isolated entity. So it has again its own endpoint. So to access the data, it has one endpoint for each protocol, and then in addition you have your management endpoint as well. So if in your company that you have different users and they want to store their data differently, and they want to make sure their data is isolated, not to be used by another project or accessed by another project, so you can create multiple SVMs for them, and they will be able to manage their own SVM on their own by using, you can provide the credential to that particular group only, and they have their own endpoints to access their data. So that's how it help if you have multiple users or multiple projects working under one file system to isolate their data. So next, let's go to the console, and we'll see that how you can create an FSX and how the whole system looks like. Okay, so I have logged in into my console, and to go to FSX, you go to all services, then storage, and there you can find FSX. So let's click on create a new file system, and just to show, I'm in North Virginia region where I have all the four options available. These all this file system might not be available in other regions, so please check the documentation if you want to create a file system in a region whether it's available or not. So click on FSX for NetApp ONTAP and click on create. Now instead of doing the quick create, because it does not give you all the options, we'll go with the standard create where it provide you all the configuration information. So first let's give a name, demo FSX, and then it asks what kind of deployment you want, multi AZ or single AZ. So to explain what is multi AZ, I would like to show you a diagram which talks where I can show you or can explain you in a better way. So let me go to my presentation and show you that how multi AZ work. So in multi AZ, what happened that, like the name mentioned, it deploy your file system in two availability zone, and it's kind of a active passive. What happened that one will act as a primary, another act as a secondary, and when it deploys to ENI as well in each availability zone. And we'll talk about ENI, what it does, how it works later in this video in detail. So what happened that whenever anyone want to access this file system by using the endpoints, they get resolved to an IP address which is mapped to this, or through a route table to these ENIs, and all the data will go through this ENI. If you're doing any activity or kind of update on this file system in the primary region, what it will do, it will route all the traffic to your backup ENI. So once all the updates are done in your primary, it will again switch back all the traffic back to your primary, and this will again become the secondary. So that's the kind of, like, if you are doing any maintenance on your file system, or you are increasing your file size or increasing your throughput, then all this activity will happen in primary and your production workload won't get impact, and all the data or all the traffic will be routed to your secondary ENI, and your system or production application will keep on working. And once the deployment or that update is complete, it will fall back to the primary ENI or primary file system. So that's how the multi AZ work. Now let's go back to our console and continue with our creation of file system. Okay, so for this demo we'll keep it multi AZ. Then we'll specify the size of the SSD storage capacity. The minimum is 1024 GB, which is I think 1 terabyte, and the maximum you can go 192 terabyte. Next, the IOPS, you can keep it automatic or you can provide your own value. Throughput capacity is by default is 128 MB based on the storage we are choosing. One thing to keep in mind, like I mentioned, that under this file system you can have one or more SVM, and this storage throughput capacity is shared by all those SVM you create under it. So there's a recommendation from AWS that if you're having 128 Mbps of throughput capacity, then you can have maximum of 9 SVMs, or basically up to 256 you can have 6 SVMs, and if you need 14 then you should approve, or you should have 512 throughput capacity. So there's a table on AWS website on their documentation. Please refer that while deciding how much throughput capacity you need and how many SVM you are using. So next, network and security. It will, because it will be deployed in a availability zone, so it will ask in which VPC. So I'll choose my default VPC, my default security group, and it will ask you that which two subnet you want to choose. So you can give those two subnets where you want to deploy this. So one will act as a primary and one will act as a secondary, and you can see the preferred and the standby subnet. If I go with a single AZ, just to show that in that case it does not ask me that two subnet, it just asks me for a single subnet where I want to deploy this. In the multi AZ, the another thing it asks me to provide the route table and the endpoint IP address range, which is not asked, or which is this feature is not available when you choose a single AZ. And what I'll do that I'll keep it the default route table, and I'm not providing any end range. And I'll explain this after creating this file system, because then it will make more sense and you'll understand that what these two values are. So I'm skipping it for now. Next, about the security and encryption, you can provide any KMS key. You can use your own, or you can use the default one. Next, for the administrative purpose, you can specify a password if you want, or if you don't need for production workload, I recommend you should have a password so that the admin use that password while doing any administrative task. Next, it will create a default storage virtual machine. So we can give a name if you want. We can give FSX1, or you can give any meaningful name. Second, like I mentioned, that each SVM has its own endpoint for administrative tasks, so you can also specify a password for that. Second, if you want, you can join this SVM with Active Directory as well. One thing to remember, that if you want to use SMB protocol, then it has to join a Active Directory, otherwise you won't get any endpoint for SMB protocol. So keep in mind, if you're using a SMB protocol, if you want to use SMB protocol. Next, like I mentioned, that the two volumes will be created. One is the root volume will be created by default of 1 GB. Another is it will create another volume at the junction path of /volume1 of size 1 terabyte, 1024 GB. But if you want to override, you can override these values. So you can say volume 1, you can provide any junction path. Suppose you say volume 5, or you say test 1, whatever junction path you want, you can give it. So I'll keep it default one. And if you don't want 1 terabyte, the minimum value you can specify the 20 MB. So I'll go with the 20 MB. Next, storage efficiency. So on this volume, it's recommended that you should enable the storage efficiency. And what it does, that it provide like the features of ONTAP storage efficiency, like deduplication, compression, compaction. So all those features will be available if you use the storage efficiency, which is always recommended to do that. Next is capacity pool tiering. So it provides the intelligent tiering as well. Like I mentioned, the ONTAP, it has a feature, and FSX with NetApp for NetApp ONTAP also have that feature. So you can create your capacity pool tiering policy, and what it does, that it has two type of storage. One is your primary, and another one is capacity pool. So what capacity pool does, that if there is any data which is the core data which is not frequently accessed based on your pattern, it moves that data to that to that lower tier of the capacity pool. And good thing about the capacity pool is that it does not, you don't need to specify any storage for that. It grows and shrinks automatically. If more data is being moved, so it will grow, and if the data is removed out of this capacity pool, the storage of the capacity pool will shrink automatically. Now here you can specify that you want to automatically let FSX decide that what data need to go there or not, or you want to apply this capacity pool tiering only on the snapshots, or you want to do it on everything or none. So based on your use case, you can decide what policy you want to apply for the capacity pool tiering. Next, you can enable the backups if you want, and you can specify your preference, that how frequently you want to take these backups and all those. Another good feature about FSX is weekly maintenance window, and this comes in your handy. Suppose you want to you have production workload running on that, and you want to make sure that my maintenance happen only during this my low peak hours. So you can specify that particular time here, and based on that, at what day, at what hours this maintenance need to be done. And if AWS need to apply any security patch or any other patch, they will do during this maintenance window only. And in the end, you can specify the tags. You can click on next. It will verify that all the details are provided, and you can verify, and then you can click on create file system. So I have already created two file system, one in Mumbai region with the multi AZ, and another one in my Singapore region with my single availability zone, single AZ. So I'll go through both of them and show you that what all the different options you have in this and how it work. So let's take a look at our multi AZ file system, which I created earlier, because creating a new file system can take around 15 to 20 minutes. So when you open the file system, you will get bunch of information like how much storage and throughput capacity is allocated, and if you want to update, you can update these, and provision IOPS as well. Down there you have bunch of tabs. First one is the network and security. Here you get the endpoints, like your management endpoints, which you can use in case you need to do any management task on your file system. And each endpoint will be allocated with an IP address. So for the management endpoint, you can see that there is an IP address of 198.19.254.17 allocated. So from where this IP address is coming? It's coming from this endpoint IP address range. Right now, this IP address range is assigned by AWS when I provisioned or when I created this file system. But if you want to use your own IP address, you can do that as well. So remember, when I was creating the file system, there was an option to endpoint IP address range. If you don't specify anything, then AWS has a predefined range of 198.19.0.0/16, and it will carve out /24 IP address range from there and assign that range to you. But if you specify your own IP range, it will use that IP range for you. So that's one thing I just wanted to call it out. And these IP addresses to these endpoints will never change once the file system is creating. They will remain constant, and I'll tell you what's the use of it and how it work in your HA environment. Next, you will see the preferred and standby subnets. So with multi AZ, remember, we specify two different subnets. So these are the two subnets, and each subnet you will get an ENI. Another thing I wanted to show that during that while creating this file system, I mentioned that VPC route table I'll talk about later on. So you have two options. One, you can use the default route table, or another, you can specify one or more VPC route table. The reason you need to provide the route table is when you create your file system, it makes an entry to your route table. So in your default route table, like I choose the default route table, it makes 1+ entries in your route table. The one entry is for your management endpoint. So this IP address .17 is your management DNS, or management endpoint DNS IP address, you can say. So this will get resolved to this IP address, and you will get an entry in your route table. Another entry of you will get one for each SVM. So right now I have only one SVM in my file system, and if I open that particular file's SVM, you will see that your management DNS and your NFS DNS both resolve to same IP address. And suppose you create another SVM, so those DNS names will resolve to a different IP address, which is also based on the range which we just discussed earlier. So these IP address will have an entry in this route table. And what is the mean of this entry? So what it says that any traffic coming to this destination will be routed to this ENI, and this ENI, which is the target, is the ENI created in your primary subnet. So if, as you see 404, and you go back to your file system, and you will see that preferred subnet ENI is 404. So now question arises that when the standby subnet will be used. So if you go to the AWS documentation and you talk about failover process for FSx ONTAP, you can see there is a bunch of scenario where it's mentioned that failover can happen from your primary subnet to your secondary subnet. One of them is like throughput capacity change. So if you are changing the capacity of your file system, or your primary file system became unavailable, or you have some outage going on your availability zone where the primary subnet is there, or any planned maintenance you are doing. So in those scenarios, the failover will happen. And like I showed in my presentation, what it will do, that it will route all the traffic from the primary subnet to from a preferred subnet to a standby subnet. One thing to keep in mind that IP address will remain same. This IP address is kind of like a floating IP address which will float between these two subnets. So your DNS will get resolved to the same IP address, but what will happen in your route table, these ENIs will get changed. So instead of sending traffic to these ENI, it will start sending your traffic to your backup ENI. And we can simulate that scenario. So what I'll do that I'll update the throughput capacity from 128 to 256, and we will see my ENIs will be changed from 404 to the ENI like F1B. And behind the scene, what it will do that it will deploy those changes in your preferred subnet first. After once that is done, it will change the ENI in your route table. It will bring it back to 404, and then it will start deploying the same changes to a standby subnet as well. So it will do it one at a time. So it will first do in the preferred, route your traffic to standby. So once the preferred subnet is updated, it will bring back the traffic to preferred subnet, and then it will make the same change to a standby subnet as well. So let me do one thing. Let me go to throughput capacity and increase it to 256, update. And you can see these updates here, that these are the two updates which I completed earlier today, and it will show you all the updates which has happened to this file system, give the history as well here. And right now you can see it's pending. If I go to my route table and refresh my page here, so it can take up to 60 seconds to fail over, but generally it just happened very quick. So let's give it a few more seconds, refresh one more time, and you can see that within few seconds all the traffic is now routed to my standby ENI. So once this file system is updated, this update is complete, then it will again change the ENI back to my primary subnet, and it will keep on showing that updating, because at the time it will be updating your standby subnet. Other than that, you will find that monitoring tab where you can monitor the storage and IOPS and throughput and all those metrics. You can see the same in the CloudWatch if you want, but here are some metrics you can check it here. In addition, you can create the CloudWatch alarm as well if you want to. Next, under administration, you will see the same endpoints, their IP addresses. If you want to update the password for your management DNS endpoint, you want that only administration or some particular people can access it, you can specify that password here and you can update it. You can change the maintenance window as per your need. Suppose you have a production workload going on and you don't want to do any maintenance at this particular time, you have some downtime in your application, you can do that maintenance during that time as well. Next, I already showed you the virtual machines, and here you will see all the volumes which are created for this virtual machine. One is the root volume, which is always 1 GB created by default. Another volume which I created while creating this SVM, and after that I added one more volume of 1 GB, sorry, 1021 MB with this. And if you want, you can create multiple volumes, you can add more volumes as well. Going to virtual machine, if I open that, you will get the endpoints of the management. You can manage the particular SVM as well, and if you want to manage or kind of connect by using the NFS DNS name, you can connect by using that as well. And if you want to update, you can specify the password. If you want that the administration task, you should use some password, you can do that as well. So that's about the multi AZ file system. And if I go back to my single AZ file system which I created in my Singapore region, so one thing, let me show you here what is the difference between these two file systems, single AZ and the multi AZ. Like I mentioned, single AZ, you don't need to specify two subnet, it will be only one subnet. Still you will get two ENIs, and these ENIs are being used to create an high available scenario within the same availability zone like you do in multi AZ. For the ENI, you will get number of IP addresses 1 plus the number of SVMs you are created, and that's same for both the multi or single AZ. In case of single AZ, you don't have any route table because you don't have any floating IP address like you have in multi AZ. So if I open the single AZ, you'll find the same information. The one thing you will see that you don't have the range, endpoint IP range. Here the IP addresses are assigned as the private IP addresses from your VPC. Monitoring is same, administration is same. The only thing, the IP address will change. Storage virtual machine is same. You can still add one or more volume. So in this case, I didn't specify any data. So when I created this file system, I didn't specify any data here. I just put it default. So like I mentioned, that if you don't specify anything, the by default it will create a 1 terabyte of volume. So here you see that you see the 1 terabyte volume. Then updates, same. If you do any update, it will show you the history. On the backups, again, if you have any backups created, you will see those backups. Under the SVM for single AZ, again you will get all the DNS endpoint, but they will resolve to your normal private IP addresses. So that's all about these file systems. I'll just wait for a little bit because right now it's updating, and once the update is complete, after that I'll come back and show you how the ENI is changed back to 404, and it will be still updating this file system to the standby node. So let me pause the video and I'll come back. Okay, so you can see now this file system is available. Now let's go back to our route table and refresh that. And you see that one IP address is, again, ENI is changed, and we should see the change for the another ENI as well. And you see, so both the IP address is now routed back to my primary subnet. And if I go back here and refresh it, it should start updating, because now what it's doing, that after updating my primary subnet ENIs to the route table, now it's updating my standby subnet. So that's all about FSX with NetApp ONTAP. Hope you like this video and learned something new today. Please let me know if you have any question by putting up the comment in the comment section. We'll be happy to answer those. And please hit the like button, share this video with your friends, and subscribe to my channel. I will upload more AWS related videos coming days. Thank you so much for watching, guys. Bye.